Okay, so this video will be about geometric probability. Our essential question we'll be looking at here is how is probability calculated for situations involving length or area? So what is geometric probability? Geometric probability is a tool used to determine the likelihood of events occurring using length or area. And when we are doing this, our general formula will be what we can see down below here, saying that geometric probability can be calculated using the following formula. Probability of A, where A is some event that they're talking about, is equal to the shaded length or area divided by the total length or area. Essentially, we will find the measurement that we want, and we'll divide it by the total measurement, whether that's in length or area. Let's give it a shot here. This first one says find the probability of a randomly dropped object landing in the shaded region. So it looks like we've got a rectangle and a triangle. Let's go ahead and find the area of that rectangle. Rectangle formula is base times height, so that would be 10 times 6, which will be 60. For the triangle formula is 1/2 base times height, so 1/2 times 6 times 12, which is 6. And then let's find the shaded part. So the shaded part will be the rectangle minus the triangle. So 60 minus 6, which is 54. And so then we will do shaded divided by total. So that would be 54 divided by 60. 54 divided by 60 as a fraction is 0.9. So that would be 90% chance of landing in that shaded part. Example 2 says a right triangle has legs with lengths of 5 and 12. So we can go ahead and say 5 and 12 there. What is the probability of a randomly chosen point along the perimeter of the triangle landing on the hypotenuse? So we want to land over here. So let me go ahead and just put an X there. And we can start off by finding that length of the hypotenuse, right? That'd be the length of our shaded portion. So that would be 25 plus 144. That's 169. So the square root of that is 13. Then our perimeter would be the sum of all those sides, right? 5 plus 12 plus 13, which would be, would that be 20? No, I'm sorry, 30. Okay, so then our final probability here would be shaded divided by total. That would be 13. That's our part that we want to land on over the entire thing, which is 30. So 13 over 30 is 0.43. So that would be a 43% chance of landing on that hypotenuse. So we can see in both examples here, we want to find the area or the length of the part that we want to land in, and we divide it by the total length. On to the inside we go. Find the probability of a randomly dropped object landing in the shaded region. Okay, so we got two parts here. We got a circle and a triangle. Let me start off by finding the total area, which would be the circle. That's the bigger part. So that'd be pi r squared. That'd be pi times 4 squared. Let's find that. I'm getting 50.3 for the area of the circle. Then for the triangle, if the radius is 4, then we could say both of those are 4. So my base would be 8. And so that would be 1/2 times base times height. That'd be 1/2 times 8 times 4, which is 16. So now let's find the shaded part. Right, the shaded part would be the 50.3 minus 16. And that's 34.3. So now we will do shaded divided by total. So that's 34.3 divided by 50.3. I'm getting 0.68. So that would be a 68% chance of landing in the shaded part. Let's keep going here. What's this one saying? Find the probability of randomly dropped object landing in the shaded region again. Okay. So it looks like we got some circles with some rectangles here. So let's start off by finding the total area again. The bigger shape is the rectangle. Now, interesting. Okay, so if the entire height of this thing is 10, that means that the radius of one of these circles is 5, which means that we've got 5, 5, 5, 5, right? So this entire distance going horizontally needs to be 20. So my rectangle will be base times height, 20 times 10, which is 200. Now for one circle, we'll do pi r squared. That's pi times 5 squared, which is 78.5. So that means that two circles will be 2 times 78.5, which is 157. And then we need to find the shaded part. So the shaded part is made up of the rectangle, which was 200, minus the two circles. So that's going to be 43. Now we just need to do shaded divided by total. So that's going to be 43 divided by 200, which gives me 0.22, which would be 22%. Okay, what do we got next? So this one says triangle ABC is a right triangle. Okay. What is the probability of a randomly chosen point along the perimeter of the triangle landing on one of the legs? Okay, so this is a right triangle with a 30-degree angle, which means that it is a 30, 60, 90 triangle. And if you remember your 30, 60, 90 triangles, if the short leg, the side that's opposite the 30, is 5, then the long leg is 5 root 3, and the hypotenuse is 2 times 5, which is 10, right? If you want to see the work there, you multiply the short leg by root 3 to get the long leg, and you multiply the short leg by 2 to get the hypotenuse. Now, what does that mean for us? That means that the perimeter would be 5 plus 5 root 3 plus 10. Let's see what that gives us. It's giving me about 23.7. And then just the length of the legs, the part that we want to land on, is 5 plus 5 root 3, which would be 13.7. So I want to do, the part that we want to land on is this part. So I'm going to do the 13.7 divided by the 23.7. 13.7 divided by 23.7. I'm getting 0.58, which would be 58%. And our last one says find the probability of the randomly dropped object landing in the shaded region. Okay, so this time we've got a circle and a hexagon. Now, this one's interesting because to find the area of the circle, we need the radius, and we don't have the radius. The radius could be drawn going from the center out there to one of the corners, though. And by doing that, remember that this angle right there formed by the apothem and the radius can always be found by doing 360 divided by 2n, where n is the number of sides. And since this is a hexagon, my n is 6. So 360 divided by 2 times 6 is 30, which means that that is a little 30, 60, 90 triangle. So what that means is that if I take that long leg and divide it by root 3, I will get the short leg. And hopefully you remember that that little part is half of the entire side. So that'll be good for later. Then I can take the short leg and multiply by 2 and get the hypotenuse. So all of that is to say that the hypotenuse of that little right triangle is the radius of the circle. And so if the radius is 8, I can do pi times 8 squared to get the area of the circle. It's giving me 201.1. Now I just need the hexagon, and we can really get going. The formula for a regular polygon is always 1/2 AP, apothem times perimeter. Now the apothem we've had from the beginning, that's 4 root 3. And the perimeter I can find by utilizing those two 4s at the bottom, right? If both of those are 4, that means that each side of my hexagon is 8, which means that my perimeter is 6 times 8, which is 48. So I'm going to do 1/2 times 4 root 3 times 48. And I'm getting 166.3. Okay, so now we're on the home stretch. The shaded region then would be the circle minus the hexagon. So 201.1 minus 166.3. I'm getting 34.8. And now I can finally do shaded divided by total. 34.8 divided by 201.1, and I'm getting 0.17, which is 17%. All right, so now it's y'all's turn to shine. You got a triangle with a little perimeter, and you've got a big composite shape that you want to land in the trapezoid. So why don't you give those a shot and then come back to see how you did. All right, so for the first one, it says that we got a leg of 7 and a hypotenuse of 25. And we want to land on one of the legs. Now, hopefully you figured out what that leg was first. That's 7 squared plus x squared equals 25 squared. It's 49 plus x squared equals 625. That's x squared equals 625 minus 49 is 576. And 576, the square root of that is 24. So this leg's 24. Which means that our perimeter is 7 plus 24 plus 25, which is, what would that be, 56, right? I think. Yeah, 56. And our legs are 7 and 24, which is 31. So we just want to do 31 divided by 56. 31 divided by 56 is 0.55. So we've got about a 55% chance of landing on one of those legs. For this part, we want to land in the trapezoid region, which would be all of this. So let's find all of our individual areas first. For the triangle, we want to do 1/2 base times height. That'd be 1/2 times 10 times 6, which is 30. For the trapezoid, we want to do 1/2 b1 plus b2, that's 10 plus 8, times the height, which is 6. And that would be 10 plus 8 is 18, half of that's 9, times 6 is 54. And then we got the semicircle, which would be 1/2 pi r squared. Our radius should be 4. Right, if that whole thing's 8, then our radius is 4. So let's do 1/2 times pi times 4 squared. That gives me 25.1. So now the total should be all of those. So 30 plus 54 plus 25.1. So 25.1, let me add all that up. Adding all of that up gives me 109.1. So I want to do trapezoid divided by total. 54 divided by 109.1 is giving me 0.49, which would be 49%. All right, hopefully that went well for y'all, and that's going to wrap this video up.